Hi, AP Calcers. We are on week 7, and here is your video. This one did not go well for a lot of you, so pay attention to what you're missing. In this particular case, they gave you find the value of this k when w is equal to 3. So what do we know? We know that we have the point 3 comma 1/9 that is on this curve, okay? And that is this point P. And then we also know if we go to take the derivative of this function, that's going to be negative 2 over x cubed. And I'm going to get the slope at x equals 3. The whole idea is I want to get the equation of this line right here, and then I can find the x-intercept. So if I find my slope, I get negative 2 over 27. And so if I write my equation, y minus 1/9 is equal to negative 2 over 27 times x minus 3. And now I'm looking for point R. Point R is the point k comma 0. So if I put that in, negative 1/9 is equal to negative 2 over 27 times k minus 3. And if I solve for k, we end up getting k equals 9/2. Now, I'm doing that to save time. I need to see your algebra behind that work, not just taking my word for it, okay? From here, they say to find k in terms of w, okay? Well, what do I know in terms of k and w is that I have, at that point, okay, in for 1/9 and in for 3, I can put the point y minus 1 over w squared is equal to negative 2 over w to the third. This is how I did it. K, and I won't put that yet. X minus w. Okay. Now, again, k comma 0 is that point, so negative 1 over w squared is equal to negative 2 over w to the third times k minus w. And if we solve for k in terms of w, we are going to get k equals 3/2 w. Okay, and again, with that, please show me your work. Okay, I'm doing it so that we save time on this. And then it says for part C, suppose that W is increasing at a constant rate, okay, which means that dW dt is equal to 7. Okay, so if I take that equation, K equals 3/2 W, then dk dt is equal to 3/2 times dw dt, and dk dt is equal to 3/2 times 7, and that's where we're getting 21 over 2 for how fast k is changing. Okay. Now, the last one, it says suppose that w is increasing at a constant rate of 7 units per second. Again, you know that dw dt is equal to 7 units per second. Oh, this was units per second. Okay, when w equals 5, what is the rate of change of the area? So you want dA dt of this triangle. Determine whether the area is increasing or decreasing at that instant. Okay, so if I look at this triangle that they're referring to, okay, this right here is W. This right here is K. Okay, this point right here is P. And that point, or that distance right here, is 1 over w squared, because isn't that the point? P is the point, w comma w, 1 over w squared. Okay, so now what is this distance? Well, that distance is just k minus w, right? So the area of this triangle is going to be base times height divided by 2, or 1/2 base times height, however you want to look at it. So I have 1/2 k minus w times 1 over w squared. Okay, what do I know? I know that there is a relationship between k and w. So what I did before I took any sort of derivative is I said, well, I know that k is equal to 3/2 w minus w, and then I have 1 over w squared. So I haven't even taken a derivative, okay? But what I have, 1/2 times 1/2 w times 1 over w squared. And if I do that and simplify it, I have area is equal to 1 over 4w. This is what I want to take the derivative of, or it is 1/4 w to the negative 1. Either way, when I go and take the derivative, dA dt is equal to negative 1/4 dw. Let's go with, okay, w to the negative 2 times dw dt. Okay, so what do I have? Negative 1/4 over 4w squared times dw dt, and evaluate that when w is equal to 5 and dw dt is equal to 7. Okay, you can go from there. Okay, so that's the first one. The second one, this one there was, yes, this one's logic, right? So explain, they give you this chart, okay, and they give you this function right here, and explain why there must be an r value for r living between 1 and 3, that h of r equals negative 5. When you're doing this, we need to see a couple things. First of all, in order to prove this, we need you to go get h of 1. And if you get h of 1, right, you are going to get 3. If you get h of 3, you should get negative 7. So this is your first step. How did I get those values? I put them in there and plugged them in. Okay, so for h of 1, f of g of 1 minus 6, f of g of 3 minus 6. Okay, now, how do I know that there needs to be a point where it's equal to? Okay, so since h is continuous, you have to decide what is going to guarantee that you will get a negative 5 for your for h. Okay, since h is continuous, remember it is the intermediate value theorem. So a lot of you did a great job of explaining that yes, negative 5 has to be reached, but you didn't tell me why. So if I put by, this is what I'm looking for, by the intermediate value theorem, but h has to be continuous, okay? So since h is continuous, intermediate value theorem guarantees there is some r that lives between 1 and 3 such that h of r is going to be equal to negative 5. So that's how you need to write that. For part B, explain why there must be for some value. Now they're talking about the derivative, right? So again, you want to go get, this is where you're looking at your mean value theorem, okay? Which tells me that the average rate of change, right? So h of 3 minus h of 1 all over 3 minus 1, okay? that is going to be equal to -5 at some point. Okay, so since h is continuous and differentiable, okay, mean value theorem guarantees this is your average rate of change is going to be equal to the instantaneous. Okay, guarantees that C is going to live between 1 and 3 such that H prime of C is going to equal that average rate of change. So instantaneous is going to be equal to that average. Okay. Next one is this guy's fundamental theorem of calculus. Okay. You've got to find W prime of 3. So W prime of X, don't put 3 in just yet, is going to be equal to, remember, this is where you plug in the top bound and you get f of g of x times the derivative of that upper bound. So this is where they get you. A lot of people got 6 on this. No, 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 okay? Remember, you're taking the derivative, you're getting rid of the integral, you're plugging in g of x here, and then you're multiplying. This is the chain rule, okay? So now go get W prime of 3 is f of g of 3 times g prime of 3, okay? Fundamental theorem of calculus. If you're taking the derivative of an integral, the integral is gone, but now you have to plug in that upper bound in for t. You can get that value on your own. Now, there were a lot of like mysterious answers on D, so I did not accept them unless you showed me some of your work. Okay, if it's in the inverse, okay, so g to the minus 1 is the inverse of g. What does that mean? That means that any point, so g of 2, if we look at our chart up here, g of 2 is, it's 3. Oh, g, do they want g of 1? Oh, at x equals 2. Here we go. So what you have to understand is that this x value for g, okay, now becomes the y value for the inverse. So if you have g is x comma y, its inverse is going to be y comma x. So g of 1 is equal to 2. So that means that g inverses is going to have 2 and it will be 1. Okay. Now, from here, okay, I don't expect you to know this, but one of the properties that you need to know properties of inverses, okay, is that when you do, okay, if you do g of g to the minus 1, oops, of x, you will get x, okay? Why does that happen? Because inverses are basically undoing the operation, okay? So think about x squared, its inverse is the square root. If I do the square root of x squared, I get x because one operation squares it and the other one undoes it, okay? Now, why do I need this? Well, if I take the derivative of this, g prime of g to the minus 1 of x times the derivative of the inside, I'm going to get 1. Now, why do I care about that? That's because now I have the derivative of the inverse here. Okay, So the derivative of the inverse, which is what I need to write the equation of the tangent line, is 1 over g prime of g to the minus 1 of x. So what do I need? I need g to the minus 1 of x equals 2. Okay. And this is a derivative. G prime of negative 1, g prime of negative 1. Okay. So now what do I have? Is I have 1 over g prime of the inverse of this right here. So now I have 1 over g prime. I know that this means that that's the y value on the chart. So I know that the x value was 1. So now I need g prime of 1. And g prime of 1 was 5, so that's how I get my 1/5 as my slope. Okay, but we had a lot of people miss that, or it was like a divine intervention. The answer got 1/5, but you had 0 work for it. That wasn't what my intent was, okay? So let me know if you have any questions. This will show up on a multiple choice, sometimes on a free response. So once I have that, you can go write the equation of your tangent line. Okay, so whatever that equation of the tangent line, you can make that. Okay? All right, have a great